Assalamualaikum and hello to all. We are now at the final subtopic in chapter 1, basic reaction of organic compound. At the end of the lesson, you should be able to describe covalent bond cleavage, whether it is homolytic or heterolytic, differentiate between the two, and define free radical and carbocation. Okay, covalent bond cleavage. All chemical reactions involve breaking of bond and formation of new bond. The breaking of the chemical bond also called fission. Fission is breaking. If it is bonded, we call fusion. There are two types of covalent bond. Fission or cleavage, homolytic, and next one is heterolytic cleavage. Okay, homolytic cleavage. The type of bond fission in which two electrons split equally. Why does it split equally? This is due to the electronegativity between these two usually almost the same, almost similar. Therefore, when this thing breaks, it breaks similarly. Okay. Okay, the arrow. This is the arrow. The arrow is shown here by single-headed arrow. Single-headed arrow here means that only one electron is being transferred. Okay, one electron to the R and one more electron to the X. And as you can see, the product here is R dot. R dot here referring to free radical. The name of something with one free electron here is called free radical. The same thing for this one. This one also free radical. Okay. The process here also known as homolysis. Each atom get one electron. This one actually from the bonding of Rx. Okay. One bond have two electron. Here we can see that one electron transferred to the R and one more electron transferred to the X, therefore producing free radicals. Okay, the resulting species are known as free radical. Free radical are, so you need to define this. Free radical are an atom or group of atom which contain unpaired valence electron. Unpaired valence electron. Okay, this is unpaired valence electron. This is unpaired valence electron. This is unpaired valence electron. Okay, so let's see this one. Okay, as you can see, the arrow single-headed. The arrow single-headed breaks homolytically. Okay, why does it break homolytically? Because A and B here have almost the same electronegativity. Okay, almost similar electronegativity. Okay, so A and B here breaks, and each one will get an electron. And these things, free radicals, are called reaction intermediates. This is not the final product because this thing is very reactive and very unstable. Okay, it will try to react until it forms something that is stable. Okay, next one. This is the next one. Heterolytic. Okay, this one different because both electron remain on one of the atom. Okay, so for example, for this one. Okay, so how can this one occur? This one occur when one of it is more electronegative. The one that is more electronegative will carry the electron pair. Okay, so this one, from the reaction here, I can see that this one is R is more electronegative than X. So in this case, what happened is both of these electron is going to be transferred to R. Okay, X here does not mean halogen. It means something else. Okay, it means something else. Maybe another methyl, but usually X is Cl, iodine, bromine. Okay, so we can see that this is not free radical because it carries two electrons. Okay, this one also not free radical because there is no electron being transferred to this part. Actually, this one is negatively charged, so this one is actually anion. And this one is positively charged, so it is cation. So heterolytic cleavage actually produces anion and cation. Okay, heterolysis produce positive ion, which is cation, and negative ion, cation. So this one is anion. I'm thinking dot ion because this is cat, right? The two shared electrons split unequally between the two atoms. Okay, and split unequally because one more is much more electronegative. So the breaking of the bond can occur in two ways, where the A gets the electron pair. Okay, maybe A can get the electron pair, or B get the electron pair. Okay, as you can see here, B get the electron pair. This depends on which one is more electronegative. For the first one, this one, A is more electronegative, so that's why it gets the lone electron, both of the electron. And here B is more electronegative, so it gets the both of the electron. Okay, earlier we see free radical and anion cation. It is actually intermediate. So there are three types actually. There are three types: free radical, carbocation, and one more is carbanion. Carbanion here is not in your syllabus, so we are only going to study about free radical and carbocation. They are unstable and highly reactive. Okay, free radical. Form in here homolytic cleavage. A radical is very reactive because it tries to find electron to complete its octet. So we can see here Cl and Cl. Okay, this one can form homolytic cleavage because Cl and Cl have the same electronegativity. Okay, so it will break symmetrically. Okay, so one electron is being transferred to Cl and one more is going to be transferred to the other Cl with the presence of UV. Yeah? So you get free radical, and it can also be a group of atom. So this one, you get this one. Actually, this one can be ethane. Okay, this one can be ethane. So actually what you get is 2 methyl free radical. Okay, or it can be another carbon here. Carbocation, very reactive species with positive charge on carbon atom. Okay, so it is a carbon atom. It is a the positive charge is on a carbon atom. Okay, so you can see better in the drawing here. Okay, in the example. So this one, we can see that Cl is much more electronegative. The sign here, D minus here, shows that Cl is more electronegative. Okay, or slightly negative. D plus means positive. So if this one breaks, the one which is more electronegative will get both of the electron. So in this case, we can see that both of the electron is going to be transferred to Cl. Okay, so actually there are 2 electron here by the at the Cl. So this one become anion, and the other one will become carbocation. So this is carbocation. So this is the carbocation that we are looking for. You can see that the positive charge is at the carbon atom. Okay, the positive charge is at carbon atom. So this is carbocation. Any alkyl that have positive charge on carbon is carbocation. Okay, so we are looking at carbon with positive charge, so it is carbocation. Actually, it is just cation, but in organic chemistry, we are going to study a lot about carbon and its properties as a cation. Okay, stability. Stability. From here, we can see that there are many kinds of carbocation. Carbocation here, as you can see, does not have any carbon attached to it, any alkyl group attached to it. So this one is methyl cation. And this one, there is one R. R is alkyl. Alkyl is carbon chain. So when carbon is attached to one alkyl group, it is primary. So this is actually primary carbocation. And so on. When you have two, it will become secondary carbocation. And if you have three, it will be tertiary carbocation. After this, we are going to relate to stability. Okay, the same thing for free radical. This one will become methyl radical if you have one alkyl group attached to the carbon with the free radical with one unpaired electron. So it will be primary. If you have two, it will be secondary. And if you have three, it will be tertiary. And remember, do not call this 1 degree, 2 degree, 3 degree. Primary, secondary, tertiary. That is the correct pronunciation for it. Okay, now we are looking at the stability. Stability of the free radical, carbocation and carbanion. We are going only to look at free radical and carbocation. Inductive effect is due to inductive effect. Okay, electron donating effect. Actually, electron donating effect is produced from EDG. Okay, G here is for group. Okay, so EDG can produce inductive effect. What is it? So it is the pool of electron density through sigma bond caused by electronegativity or charge differences of atom. Okay, you are going to see better after this. The alkyl group has electron donating group. Any alkyl group, it means that whether you have methyl, ethyl, propyl, and so on, as long as it is alkyl group, it will have electron donating effect, because this thing is EDG. Okay, this thing is EDG, electron donating group. And due to the presence of EDG, electron donating group, or alkyl group here, it increases the stability. The greater the number of alkyl group of the carbon atom, the greater its stability. So let's see the stability. So as you can see from here, this is carbocation. Okay, this is carbocation. So carbocation, when you have R, okay, this one is the least stable. Okay, methyl carbocation is the least stable. Okay, why is it more stable? Carbocation, as you can see, it is positively charged. So in chemistry, something that is too positive or too negative is not stable. So R is EDG, so it will donate the electron cloud, okay, to carbon here. So carbocation now become less positive, okay, because R is donating electron. Okay, so when it become less positive, okay, so it is more stable. Okay, we can say it is more stable. So the same thing for this one. There are two R, so there are two more R to donate the electron cloud to carbon. So carbon become less positive. Okay, the same thing for this one. There are three R, so it become less positive. Okay, so which one is the most stable? So tertiary. Why tertiary? Because it have inductive effect from the three alkyl group that attach to it. Okay, the same thing for this one. Free radical. Okay, for free radical, the stability, the same thing. Carbon supposedly have two electron, but now it have one. So R will donate the electron cloud to make the free radical become more stable. Okay, so this one the same. Tertiary is the most stable. Okay, stability increase. The tertiary is most stable. Okay, so let's try. Show how the electron in CX. So we are looking at this part. Okay. CX bond in the compound below are distributed in the bond cleavage to form free radical and carbocation. Okay, so you can try to do it for yourself first. and can come back to this video later. So you can pause this video now. Okay, so next, let's see. Okay, free radical. If you want this one to form free radical, it means the X must be something that is having similar, almost similar electronegativity with carbon here. So what happened is this bond, okay, it become like that. It will break symmetrically. So these two will break into free radical and another free radical. So this one for the formation of free radical. So it breaks symmetrically. Okay, carbocation. For carbocation, it means that X is more electronegative, right? Okay, so this one will become more electronegative. So this one is D plus. Why? Because all of the electron will be transferred to X. Okay, all of the electron is going to transfer to X. So what's left for you is a positively charged carbon. And this one will become an ion because it carries both of the electron. Okay, so that's it for part 1. There is part 2. Good luck.